going to start here with a learning check. So what is the process shown by these blue lines here? And then number two, what is the blood vessel depicted here? So for this second one, I'm going to show another image of it. There are two options actually for the name of the blood vessels, these capillaries that surround the nephrons. This is the paratubular capillaries. If you answered vasa recta, that's fine. Both of those capillary beds are going to be important in different types of nephrons as we start talking about reabsorption in more detail this week. So last week we talked about urine and the changes that occur when we're going from plasma to urine. So we're going to be secreting some things, retaining a whole bunch of stuff, mostly nutrients, and then regulating a whole bunch of stuff. So water and electrolytes all are variable in concentration in the urine. And this is due to the processes that happen throughout the nephron. So you remember, we've got filtration occurring here. And so this is going to make our filtrate. What osmolarity do you think our filtrate is? Well, it's 300 milliosmoles, just like our blood. So our blood is 300 milliosmoles. So is our filtrate at the proximal convoluted tubule. That's going to change as we get down to our nephron loop, our distal convoluted tubule, and then our collecting duct. This is going to then enter our papillary duct, calyces, renal pelvis, and ultimately ureter. Okay, so what happens to change the osmolarity of this filtrate? Well, reabsorption and secretion are both going to occur. So reabsorption is when fluid and all the substances exit the nephron. About 65% of reabsorption is going to occur in the proximal convoluted tubule. So that is electrolytes, water, about 100% of our nutrients actually at this point, so glucose, amino acids, are reabsorbed. And we will look at this in more detail. So we do have some secretion also occur at the PCT. I guess I will add in a little arrow showing you that. So here's secretion, hydrogen ions, some drugs. Then we're going to go down the nephron loop. As we descend down the nephron loop, water is reabsorbed. So that is going to be this H2O, and about 15% of the water is reabsorbed at this point. Some has already been reabsorbed here, water, electrolytes. When water is reabsorbed, what do you think is going to happen to the osmolarity of this filtrate? Water is leaving, right? So solutes are going to become more concentrated. So as we descend, we're going to go from the 300 milliosmoles to 600 to 900, ultimately to 1200 milliosmoles. As we ascend up the ascending nephron loop, we are going to have reabsorption of electrolytes. So this is where sodium, chloride, potassium are going to be reabsorbed. And because of this, we are diluting, we're removing those solutes, right? So we're going to reduce osmolarity again. So we're going to have something like 700, 400, 100, 100, super low, right? We'll look at why that is. In the distal collecting duct, we've got both secretion and reabsorption. And we will primarily here talk about, what did I just say? Secretion and reabsorption. We will primarily talk about the secretion of potassium and drugs. We also do have some regulated reabsorption that we'll talk about. So at this point, we have about 10 to 15% more of our water reabsorbed. That is, oops, I have that last arrow the wrong way, right? Because reabsorption should be this way. This is regulated. We'll talk about this, sodium, water, and we've got about 10 to 15% more water reabsorbed. So by the time we get to our collecting duct, we have had almost all the water reabsorbed, but we do have regulated reabsorption here. So it's variable what water reabsorption occurs in the collecting duct. So what that means is basically from here on, we've got a lot of regulated processes. We're entering the distal collecting duct with an osmolarity of about 100, sometimes 150. By the time that gets through the collecting duct, the distal convoluted tubule in the collecting duct, that urine can be either anywhere from 100 to 1200. 1200. 12. Yes, 1200. 1200. 1200 milliosmoles. So that's dependent on what happens in the distal collecting duct, distal convoluted tubule, DCT, and the collecting duct. So how much water is reabsorbed and how much sodium is reabsorbed, how much potassium is secreted.